Okay. So just a second. Okay, yes. So let us see that how different links are fixed and how the whole mechanism become a different one. Okay, giving different outputs. Okay. Next. So first one is the single pendulum pump or bull engine. Okay. So in this, what is done? The same thing, that your cylinder is fixed. See, your cylinder is fixed. Okay. Now, what will happen here, as this crank will rotate? Okay, as this crank will rotate here, this crank will rotate about this point, and you do not assume that this point is on this piston rod. Okay, there is no connection between this piston rod and this point. This point may be up. Okay, so when this will rotate, what will happen? This connecting rod will oscillate here like this. Okay, so and when it will oscillate, at that time this piston will reciprocate in this cylinder like this. Okay, so this rod will reciprocate in this cylinder as well as in this cylinder. It will reciprocate here also, and you can provide one more piston here. You can provide one more piston here, which will be connecting this piston rod. So you can get the motion of piston at two sides. Such a mechanism is called as a pendulum pump or bull engine. Okay, and it is used to supply the feed water in boilers. Okay, this crank will be driven with the help of some engine. Okay, or with the help of electricity. Okay, and this rod will reciprocate here, and it will supply the water to boiler with the help of pumping action. Okay, so this is one inversion, and this inversion is same as your IC engine. IC engine is another example of the first inversion of the single slider crankchain. Okay, what is done there in IC engine? Depending on application, we have given different shapes and sizes to the different links. Okay, otherwise overall motion is same in IC engine. Next, let us see the next. Next is your oscillating cylinder engine and crank and slotted lever quick return motion mechanism. So both of these mechanism are same inversion, and how they are obtained? They are obtained by fixing the link 3. Link 3 is our connecting rod of the slider crank chain. Okay, so see here, connecting rod is fixed. Now what will happen to cylinder? See, कनेक्टिंग रॉड यहाँ पे फिक्स किया है, और थोड़ा जो है सिर्फ पोजीशन डिफरेंट है, इसमें जो पोजीशन है वो डिफरेंट है. सो इट इज योर पिस्टन रॉड. See, piston rod is rigidly connected to the piston. When this piston will slide into the cylinder, okay, this piston rod will also slide like this into the cylinder. Okay, so when this crank will rotate, you can see that this piston rod ka end, it will go into a circular path like this. So suppose when it will come, when this piston rod ka end will come here at this point. Okay, so as cylinder is pivoted, pinned here. So what will happen to the cylinder? Cylinder has to change its orientation like this. So cylinder will oscillate. It will oscillate about this point because cylinder is pivoted at this point. As this piston and piston rod, okay, they will move into the cylinder. The cylinder will oscillate. Yes, any problem? Uditangshu, any question? Okay. So are you, yes, are you getting the working of it? How connecting rod is fixed? Or should I explain it to you with you basic figure? Okay, for example, I will explain it with you to you with our basic figure. Okay. See, it is our slider crank mechanism, slider crank chain. Okay. Now, what is done here? See, it is your cylinder. Suppose that your cylinder is not fixed, as in case of IC engine. Here, your connecting rod is what? Connecting rod is link 3. So instead of fixing cylinder, what I am doing? I am fixing the कनेक्टिंग रॉड. अभी कनेक्टिंग रॉड मूव नहीं हो सकती, ठीक है, like this. Okay, now what I have done here, that this cylinder I have pivoted at this point. यहाँ पे इसको पिवोट किया है, मींस पिन जॉइंट से यहाँ पे इसको कनेक्शन दे दिए. ओके, एंड दिस पिस्टन को एक्सटेंड किया. दिस पिस्टन is extended like this with the help of piston rod, and the point A is now not fixed here. Point A is free. Okay, so what will happen here? When you will rotate the link to, when you will rotate the link to about the point B, now about the point B, then what will happen? As point A will move like this, point A will go like this in a circular path, then this piston has to come forward in the cylinder. Okay, when piston will move forward in the cylinder, okay, what will happen to the cylinder? This cylinder will oscillate because its angle will change. The piston is free to reciprocate in the cylinder. Got it? So what you get here is a oscillating cylinder mechanism. Here cylinder will oscillate. Okay, so this is the mechanism when you fix the link 3, that is connecting rod. If you will say that let us free the link 3 and let us check what will happen if you fix the link 2, okay, then you will again get a different kind of motion. Okay, we will see that. It is that mechanism. It is called as oscillating cylinder engine mechanism. Okay, this mechanism is used in earlier ships. Okay, and they are used in steam engines. So steam will come here. This engine will oscillate, and its motion will be transmitted to the crank, and your ship will be propelled. Okay, I will show its animation also. Okay, and second is the crank and slotted lever quick return motion mechanism. So it is also the same inversion, that when you fix the link 3, that is your connecting rod. Okay, so whatever motion of cylinder you are getting, you can utilize that motion to convert it into a crank and slotted lever mechanism of your shaping or slotting machine. Okay, so how the arrangement is that for you see, it is like this. Okay, see what is done here. It is your connecting rod which is fixed. Okay, it is now crank is rotating about point C. See here the crank CB. Okay, CB will rotate like this. So this point B will be moving along the circular path at it will also come at B2, then it will also come at B1 like this. And when this crank will rotate, okay, the piston is attached to the crank. Piston is attached to the crank, and this piston is in the slotted lever. This slider is in the slotted lever. It is kept in the slotted lever so that this can slide in the slotted lever. So when this piston will also rotate, okay, what will happen? This piston is bound to slide into the cylinder, into the lever. Okay, it is a slotted lever, and this slotted lever will oscillate. This slotted lever will oscillate between the points P1 to P2 like this. It is the path. It is the path of the slotted lever P1 to P2. Okay, and path of the crank is the a complete circle. In order to utilize this oscillating motion of the lever, okay, we have connected additional links here. So link PR is additional, and at R point of the link, okay, ram is attached, ram with cutting tool. Okay, so when this oscillating lever will oscillate, this cutting tool will reciprocate in the given straight path. Okay, and by reciprocating motion of the tool, you can cut the slots in the metal sheets. Okay, when it will reciprocate, it will do the cutting operation also. Now why it is called as your quick return motion mechanism, quick return. Okay, so you see the angular movement of the crank CB. Okay, so after that I will try to wind up. Okay, so you see the motion of link CB. Okay, when link CB is at position CB1, at position CB1, at that time, this lever AP, this lever is pin jointed here, pivoted here at point A. So position of lever AP will be at A P1. This lever will be here when crank is here. Now from point B1, when crank will rotate like this, when crank will rotate like this, then the lever will move from point P1 to point P2. Okay, and crank will move from point B1 to B2 like this, B1 to B2 through angle beta. Okay, so you can say that through angle beta, forward stroke of tool takes place. Okay, and this forward movement of tool can be used for cutting operation. During forward stroke, you perform the cutting operation. Okay, and then what will happen when crank will move from B to B1, means through the angle alpha. When it will move from B to B1, at that time your lever will come back from P to P1 to its original position. P to P1. So after cutting, your tool will come back to its uh, original position, means it will return to its original position. Okay, but what is the angle through which the crank has turned? Only through alpha. Okay, and alpha is your less than beta. Okay, though motion is equal. Okay, but you are returning back very quickly. You can see the angle because this crank is rotating with uniform speed. Okay, means your forward stroke has larger angle beta and return stroke has smaller angle alpha. That's why it is called as quick return motion mechanism. Quickly your lever will come back to its original position, and it should happen. Okay, because what is happening during cutting you should control the speed of tool. Okay, tool should move slowly because there is material resistance. If you move faster, then it might happen that tool might get damaged. Okay, but in return stroke, what will happen? In return stroke, the material is already cut and there will not be resistance to the tool. Okay, so even if you come back quickly, okay, it poses no problem. Got it? Slotted lever quick return mechanism. I will also show you the animations. Okay, but we will cover it in next class. Okay. I think some points are to be noted here. Just a second. So quick return ratio is defined. How it is defined? It is the ratio of time of cutting stroke upon time of return stroke. This time is no doubt proportional to your angle beta and alpha. So beta you can find out by the equation 360 minus alpha upon alpha. Alpha, you know that alpha is the angle through which the lever comes back, returns back to original position. You note it down, then we'll stop here and we'll continue next class. I will also show you the animation of the same. Have you given the attendance, all of you?
Yes, sir.
Yes, please type your attendance. Do not forget. Then I will end the meeting in 1 minute. Okay.
So I have not received an opportunity, like spending.